on to set 6.2, and we're going to look at three different matrix operations: addition and subtraction, multiplication with a scalar, and matrix multiplication. Now, the only one of them I expect to be any kind of an issue at all is matrix multiplication. Now, in the first example, if you look at the triangle ABC up here, and you can read the vertices for yourself, there's a matrix down here that represents the triangle. You can see that the point A has coordinates 1, -2. B, you can look up there, -2, 2. Now, we're going to take that triangle, and we're going to move it to the right 4 and down 2. From geometry, that's a translation. Now, the matrix written right here is the translation matrix. First row is called delta x, which means change in x. And if you read the entries right there, you're going to see that we're going to go right 4, or we're going to add 4 to every element in row number 1 here. Now, delta y is change in y. This is the down 2. We're going to take every element in row y down here, and we're going to add a -2 to it. When you get done, you end up with the matrix here that's labeled A prime, B prime, C prime. There's a triangle A prime, B prime, C prime. And if you look at A prime, you can see that that point is 5, -4, and it's 5, -4 here. If you take a 1, add a 4, you get the 5. You take -2, add -2, you get the -4. Like I said, I don't think matrix addition is going to be any kind of an issue at all. There's an example how you use it. If you want to stop the video and take a look at it, you certainly can. Now, next example, again, comes from geometry, and this is scale change. We've got the same triangle, A, B, C, but this time we've done a scale change of magnitude 3. So if you were to look at, let's say we decide to look at point C. The original point C is the point 1, 3. C prime up here is the point 3, 9. Both coordinates have been multiplied by 3. Well, the way you write that, you can see down here is your matrix for triangle ABC. This multiplier up here is just a plain old number. It's called a scalar when you use it with multiplication because it causes a scale change. So if you multiply 3 with the matrix, you just take every element in the matrix and multiply it by 3. So the 1 becomes a 3, the -2 becomes a -6. Again, I don't expect that to be any kind of an issue. Now, next example is for matrix multiplication. You'll notice that we've seen this problem right here before. This is the problem about the bathroom tissue on the little island. And the text is highlighted in yellow, says, on the little island there are 2 small towns, town 1 and town 2. In town 1, 40 people use rough stuff, 50 people use clean sweep, and 10 people use tender tushy. In town number 2, 30 people use rough stuff, 20 people use clean sweep, and 50 people use tender tushy. What we're going to try and find out is how many people are going to use each brand of bathroom tissue in the very next week. Okay, now the initial matrix right here, and you'll see the same thing, the same terminology in your book. Town number 1, 40 people right now are using rough stuff, 50 clean sweep, and 10 tender tushy. Same thing it says up there. So we're just keeping track of how many people are using each brand right now. The transition matrix is the same one that we set up yesterday. Now, what you'll notice before we do the multiplication is that these column names, rough stuff, clean sweep, and tender tushy, and more importantly, rough stuff, clean sweep, and tender tushy right now match these row names, rough stuff, clean sweep, and tender tushy. If these column names don't match these row names, you can't multiply. Now, you can get your calculator out and do this multiplication. And on your calculator, you'll get a matrix that's got a row number 1, which is town number 1, comes from over here. Rough stuff, clean sweep, tender tushy. But this is next week. We've got 43 people using rough stuff, 38 people using clean sweep, 19 using tender tushy. In town 2, you got 41 and a half people, which I know is impossible, but the math doesn't know that. Using rough stuff, 26 and a half using clean sweep, and 32 using tender tushy. So you multiply the initial matrix with the transition matrix. It tells you who's using what next week. Now, we've got to look at is how this works and why it works. Now, first thing to notice, the initial matrix I've used an I for is 2 by 3. The transition matrix is 3 by 3. And again, these column names match these row names. When you multiply, you get the next week matrix, and it gets its row names from the initial matrix and gets its column names from the transition matrix. And it ends up being 2 by 3. 2 by 3. Okay, that's what happens. Now, why does it happen? These are the rules for matrix multiplication. In the next week matrix, in town number 2, right there, we've got 32 people that are using tender tushy. The element is in row 2, column 3, or if you'd rather, it's in row 2, column T, however you decide you want to look at it. Now, where'd the number come from? Well, it came from row 2, column 3, or if you'd rather, row 2, column T. Now, what you do when you multiply, and you do this for every element in this matrix, but I'm doing it just for the 32 that's in row 2, column T. You take the elements in row number 2 from the first matrix. You take the 30, the 20, the 50. 30, 20, 50. And match them up with the elements in column T. The 0.1, the 0.2, and the 0.5. You multiply them together. So you take 30 times 0.1, you get a 3. And you can see the others. Add them up, and you get 32. Now, why do you do it? Because right here in town number 2, you got 30 people using rough stuff. And right here from column T, you're told that 10% of the people that use rough stuff are going to switch to tender tushy. So when you multiply the 2 together and get 3, those are the people that are going to change from rough stuff to tender tushy. So again, what you take a look at, the 30 comes from row number 2. People are using rough stuff right now. The 0.1, 10% are going to change from rough stuff to tender tushy. Okay, so 10% of the 30 are going to make a change, rough stuff to tender tushy. You multiply and you get 3. Now you get down to the next multiplication. These 20 people are using clean sweep right now. This number right here says 20% of the people that use clean sweep are going to switch to tender tushy. So you take the 20 people using clean sweep, you multiply by 20%. This 4 says 4 people are going to make the switch from clean sweep to tender tushy. Okay, there are 50 people that are using tender tushy in town 2 right now. This number says that 50% of the people that use tender tushy will stay with tender tushy. So you take 50 times 50%, you get 25, and you add them all up. These are the number of people that are going to use tender tushy next week. Okay, so go back and take a look at what you do. If you want the number that's in row 2, column T, you take row 2 from the column, or row 2 from the first matrix, match it up with column T from the second. You can see them matched up together here. Multiply, add, and put it into row 2, column T. you got matrix multiplication. If you wanted to find the number that's in row 1, column R, right here, you'd take row 1, match it up with column R, multiply and add, and you get 43. Now you can try that for yourself. Okay, now I know that when you multiply, you can do it on your calculator. However, there is a way, especially come test time, where I can find out whether or not you know what you're doing. I've got a matrix up here that's 2 by 3. Right next to it is a matrix that's 3 by 4. When you multiply them together, we're going to take the row names from the first one, column names from the second one, and you're going to get a matrix that's 2 by 4. Again, 2 and a 4. Now I've called that matrix C. Now I want to find just one element in that result matrix. I want to find the element that's in row 2, column number 3. So I go to row 2. This is right there, column number 3. I want to find that number. Now, how do you get it? You take row number 2 from the first matrix, 1A5. I like to write it vertically, 1A5. Multiply it with column 2 from the second matrix. Why? Because this number is, or column 3, I should say, from the second matrix. Why do you do it? Because this number is in column 3. So you write down 4, 5, and 6. 4, 5, and 6. 1 times 4, 8 times 5, 5 times 6. And the number that would go in this spot right there is 34 plus 5a. You can't do that on your calculator. You got to do it yourself. Okay, finally, I want to take this matrix, which is 3 by 4, and I want to multiply it with a matrix that's 2 by 3. 4 does not equal 2. You can't match them. Don't multiply. You can't do it. And that, folks, is the end of matrix multiplication.